During Saturn V engine tests, the roar shattered windows in nearby houses. The rocket was built to carry astronauts toward the moon, but its first shock was on Earth. Saturn V was NASA's three-stage, liquid-fueled vehicle for Apollo. Its engines had to be tested on the ground before astronauts could trust the complete launch system. The three stages handled different parts of ascent. Ground testing had to examine the enormous vehicle before crewed lunar missions. The main source was the first stage. 5 F-1 engines fired together. They produced an extraordinary roar, and that sound reached structures beyond the test stand. Testing happened before Apollo 4, the Saturn V's first launch in November 1967. The result was not just engineering data. Nearby houses had shattered windows. That damage made the rocket's scale visible at ground level. A vehicle designed for lunar missions had already affected local infrastructure before carrying a crew. Crystal Springs Dam survived the 1906 San Francisco earthquake with minimal damage, even though it stood about 1,100 feet from the San Andreas Fault. The dam sits in a valley formed by the fault and stores drinking water for San Francisco. That required a large, dependable reservoir. Construction finished in 1889 before either earthquake occurred. Builders poured the dam as separate, interlocking concrete blocks, each about 7 to 9 feet thick. They let each block set before adding its neighbors, limiting cracking during curing. This approach made a mass concrete structure, a heavy body whose weight helps resist water pressure. The joints were staggered horizontally and vertically, so seams did not line up through the structure. That arrangement helped thousands of blocks behave as one mass during shaking. The design did not eliminate risk, but it avoided one continuous break across the dam. That same dam also survived the 1989 Loma Prieta earthquake with minimal damage. Today, it remains part of San Francisco's water system. The surviving structure continued serving San Francisco's drinking water system. A bank that rejected solid walls for glass facades and an open plan became a National Historic Landmark. Its designation recognized architectural significance. In downtown Columbus, Indiana, J. Irwin Miller commissioned Eero Saarinen to design a new branch. It opened on March 10, 1955. The project replaced an overcrowded earlier bank location. The one-story square hall used glazed panels from low limestone edging to the concrete roof. Inside, tellers' counters sat in an open plan rather than enclosed banking rooms. 9 shallow roof domes divided the ceiling into a 3x3 grid. The building also stepped back 12 feet from the sidewalk. Dan Kiley surrounded it with trees and lawn, while a drive-through facility extended the bank's footprint beyond the hall. The bank occupied only part of the site, leaving room for the landscape and customer circulation. Those elements were evaluated together as an architectural work. That is why the building received National Historic Landmark status for architectural significance, not simply because it operated as a bank. In 2006, a practical Australian pickup became the world's fastest production utility truck, averaging 271.44 kilometers per hour. Its utility shape made the result look more like a work vehicle than a speed machine. The vehicle was a Z-Series Maloo R8 built by Holden Special Vehicles as a performance coupe utility. Its 6-liter LS2 V8 supplied the power behind this record attempt. Mark Scaife drove the Maloo across the Woomera prohibited area in Australia. The official test used 2 runs, one in each direction. Into the headwind, it reached 265.72 kilometers per hour. With the tailwind, the same truck recorded 277.16 kilometers per hour. Those measurements were averaged for the official speed. The opposing directions helped account for wind. That calculation produced 271.44 kilometers per hour, the Guinness World Record for a production utility or pickup truck. It beat the previous Dodge Ram SRT-10 record by more than 20 kilometers per hour. This was a category record, not a claim for the fastest production car overall. Chicago's Inland Steel building looked like a modern office tower, but a railroad-like track on its roof served a practical job: washing the windows. Built from 1956 to 1958, the building rose 332 feet, with extensive green-tinted glass across its office facade. That created a tall exterior surface requiring dedicated maintenance access. The design split the building into a 19-story main structure and a separate 25-story mechanical tower. Exterior columns carried the building's entire weight, leaving the office floors largely free of interior columns. That tower held stairs, elevators, and utility ducts. Above the third floor, the facade had to be cleaned from a suspended scaffold. Mechanical arms ran on a narrow-gauge railroad track along the roof perimeter, guiding access to the glass. The first 2 stories could use standard window washing equipment, but floors 3 through 19 required this roof-based system. So the track did not carry trains or people. It positioned window washing equipment where the building's sealed glass could not be reached from inside. The modern facade depended on that rooftop infrastructure to remain usable. A Portland shipyard known for repair work built the Portland, identified as the last steam-powered sternwheel tugboat produced in the United States. Northwest Marine Iron Works was organized in Portland in May 1943. It operated at the port of Portland's Swan Island shipyard. The company had a repair base, not simply a production line. Its work centered on ship repair and ship conversion, adapting vessels rather than only building new ones. By 1968, it handled about half of Portland's dry dock and ship repair work. In 1974, it agreed to construct 3 barges for a trade link between Oregon and Alaska. That industrial capacity also produced other vessels, including USNS de Stager and USNS Bartlett. The Portland appears in the company's construction record as the last steam-powered sternwheel tugboat produced in the United States. Together, these records show a mixed industrial role. A repair yard's record preserves a specific endpoint. The Portland connects Swan Island's industrial work to a distinctive riverboat technology no longer produced in the country. Mitchell Sabattis was not only an Abenaki guide. He is credited with co-inventing the Adirondack guideboat, a regional watercraft linked directly to the Adirondacks. The Abenaki are an indigenous people of the northeastern woodlands in Canada and the United States. They are part of the Wabanaki Confederacy and speak Algonquian languages. This places Sabattis within a specific indigenous community. His role supplies the bridge between guiding and design. Sabattis is identified as a guide, connecting him to travel on local waterways. That same guide is credited with co-inventing the boat associated with the Adirondacks. The result has a precise name, the Adirondack guideboat. It is the specific watercraft attached to the co-invention claim. The record does not name the other co-inventor or describe construction details. No dimensions or materials are supplied. That limitation matters. The evidence supports crediting Sabattis as a co-inventor, not calling him the sole inventor. Boat history can preserve the contribution of a working guide, not only a formal manufacturer or institution. A Singapore movie theater was given an unusual brief. Architect Jeff Malone had to impress visitors with a rocket ship design. Malone was an Australian architect based in Singapore. His cinema work made the rocket ship brief one assignment within a wider portfolio. That portfolio included both newly designed cinemas and renovated theaters in Singapore. The mechanism was visual. The theater's identity was framed through a rocket ship concept instead of a conventional cinema form. In practice, the arrival experience began with a recognizable shape before the film itself. The available record does not name this theater or give its dimensions. It also does not confirm whether construction followed the concept exactly. Malone's documented cinema work included Yishun 10. He also renovated the Savoy Cinema and the Republic Theater, showing that his practice covered both new cinema projects and existing venues. His architectural work extended beyond cinemas. After visiting the Mill Valley Film Festival, Malone founded the Singapore International Film Festival in 1987. Later, his film work added a public festival platform to that architectural record.